Hi, welcome back. So we are in section 1 to speak about object-oriented analysis, design, and programming. Let's check out the outline that we're going to be discussing in this very first section. Essentially, we're going to be talking about object-oriented and its features. So we'll be looking at the actual title, object-oriented analysis, design, and programming. And we see how those features actually are relevant to the term of object-oriented. In the second outline, we'll be discussing two different paradigms. One of them is called procedural, and of course, the current subject of discussion, object-oriented, and we see the difference between them. In the third outline, we're going to be talking about what is actually object and class from the perspective and the implementation idea. And then we'll be looking at a tool which is called the UML, a Unified Modeling Language. It's a very popular kind of tool used actually to model a class and objects. And then we'll be talking about the four important terms when it comes to speak about object-oriented. That is called the encapsulation, inheritance, polymorphism, and a composition. Last but not least, we'll have a quick abstract idea on how to think in terms of objects. Keep in mind this very first kind of section, it's going to be much more to lay out all the fundamentals from abstract point of view. You are not going to expect too much actually kind of a coding there until we start actually section number 2. But for now, if you have come to understand every section or outline inside the section 1, I can guarantee you that you will have all the fundamentals from abstract and theoretical aspect on why object-oriented is a very, very interesting kind of a framework. So without further ado, let's go and discuss the first outline, and that is object-oriented and its feature. As you can see from the term here, object-oriented, and it is associated with three different terms, that is analysis, design, and programming. And this is one of the things that we say feature enhancement on the training program, that we wanted to discuss object-oriented beyond just only programming. But we wanted to bring the analysis feature into it, the design, and finally the programming. So let's go ahead in this outline and break down actually each one of these components on its own. Let's first of all discuss what do we mean with object-oriented. You could see these are two different terms. There's an object and there is an oriented. So what do we mean with object exactly? I want you to understand here we don't actually imply a tangible things on its own. We have to sense it or pick it up or feel it. But what we are trying to say here, object implies anything that we can inform two important terms with it. That is data and that is behavior. In other words, to say object actually is a kind of a collection of data associated with certain behavior. And finally, they can be actually belong to a specific kind of entity. Let's go ahead and discuss the second term that is associated with that. That's orientation or oriented actually. It means directed towards something. I mean, from the English dictionary perspective. But what is important for us actually here is to see how these two terms come together to form what's called object orientation. That means the functionality directed towards modeling object. Okay, let's just kick off with an example that makes sense on what I was trying to say here. In this example, let's just try to look at a tangible one. Tangible, what I mean, something that we can touch and feel. So let's take this particular object, bring this particular term that we're talking about, data. What do we mean with data? Well, this object now, it has a specific attributes related to it, attributes or properties. In a while, you will see that so many terms are used interchangeably, but all they are meaning the same. So what kind of data about this cup that I have? Well, I can say the size, I can say the color, the date of production, the type, etc. So many attributes that I can actually associate with the cup. And that represents the meaning of data about a cup. Great. So let's look, what do we mean with now behaviors? That is the second term to form the meaning of object. Well, behaviors maybe is a kind of the action that I can do in this particular object. For example, I can fill up the cup with something, I can empty, I can clean, I can paint the cup, etc. So what happened here, we are trying to show you that these two terminology come together to form actually the identity of this object. Very interesting thing. Now let's go ahead and look at the actual directionality between this what's so-called behavior to the data. So you can see that I can actually associate this verb to the whole data as once, as the object. For example, I fill the object with a certain other object, maybe a liquid of tea, or I empty the object from something, or I can apply actually a specific word to a specific property. For example, I paint the color of the object. So I want you to start to think of from that. It's a language kind of tricky sometimes to understand, but believe me, if you got to start to visualize things from that perspective, it means you understand what is object-oriented is all about. The last kind of a term brought to the first definition of data, behaviors, and entity, it's the ownership of this cup could be belong to a specific entity, maybe belong to a one person or more than that. I want you to remember this side note very, very well before we actually move to the second term of analysis. Number one, I want to tell you this word of data that I have chosen to use here in so many different books are used interchangeably in a different way. For example, in some they call it nouns, in others they call it adjectives. Because look at the word here, color, it's an adjective. Size, it's a noun. Data of production, it's a noun. Type, etc. Other books, they refer to it as an attribute, characteristic, properties. All these terms are actually used to reflect the exact meaning as I meant here, but I use the word data as a generic. Also, we use sometimes field, for example, when we are talking about this from database perspective, or we use it as a variables when we speak about mathematics. So please keep this side note in mind. The next word about behaviors here, in some books, they refer to it as a verb. You can see that it's a very obvious verb to fill or to empty something, or as an action. Interactions and methods also from programming perspective. So all these terms are referring to the exact same thing, and that meaning of behavior. The last important part of this side note, I wanted to draw your attention one more time about the behaviors. I actually mentioned very quickly just a short while ago. When I said fill, now when I want to fill, I apply this verb on the object itself. So I want to fill the cup or the object with a certain liquid here in tea. But sometimes I can use the behaviors or the methods here on a specific property of the cup. Example, look at the word paint. So I want to paint a color of the object. So what we are trying to say here, behaviors sometimes are applied on the object as at all, or sometimes can be applied only on one of the characteristics of the object. Just keep that in mind. Everything will make sense as we start actually practical examples. Now let's go actually and discuss the second term, that is analysis, since we understand what we mean with object and oriented and how they form the concept. So what do we mean with analysis? Here is the popular term you can see in so many books called object-oriented analysis, or OOA. It means the process of looking at a problem or system or task that is or that somebody is actually desired to find a solution for. So what we are trying to do in analysis to identify objects and interactions. This is the first skill you have to learn when it comes to create a product based on object-oriented framework. So you should understand how to do analysis to define what are the objects exist, what are the interactions or the behaviors. And this is one of the most important aim in this course, to show you actually how you can do that. And here is a very important things to observe in this stage of analysis when it comes to object-oriented is we need to, it's all about what needs to be done. Let me give you an example. Let's say you are requested to create an app as a website service for any reason, doesn't really matter. So when you want to do analysis on this particular problem to create the solution you desire for, you are going to come up with certain kind of sentences or statements as you go along the line. So maybe you need to look at the website. Visitors need to be able to do certain things inside your website. Now here I'm gonna suggest 3 of these things that we think that a website visitor would do. What I did, I'm gonna refer to the actions or the verbs or the interactions, don't remember the behaviors, in italic written, and the objects in a bold written. Let me give you an example. Let's say we need our visitors of the website to review the history of the website or whatever they have done inside the website. So here I want you to look carefully to the word history. History here represents an object. Review, the verb, it's gonna represent an actions or the verb. Look at another example. Apply for a job. Job here represent an object, and apply is gonna represent a verb. And of course, you can continue with different things. You can browse, compare, and order product, etc. So here is the 3 important terminologies difference, like history and job and product. They are all representing the meaning of objects that we can create for this problem. And look at the verb of review and apply and browse and compare. These are representing the behaviors that I can apply on those objects. Now, the next terms to discuss the term of design. And I think it's self-explanatory. What do we mean with design, or in some books referred to as OOD or object-oriented design, is actually the process is to convert the analysis that you have done or requirement into kind of implementation specification. So you need to make sure that your design must have name of the object, of course must define the behaviors, and of course formally specify which object can activate specific behaviors on other object. I know this term might be a little bit kind of tricky to understand for now, but believe me, as we go along, you will see a lot of examples to explain that. But the important things I want you to remember, design here represent how things should be done. So in the analysis, what should be done, in the design, how can be done. So design is to design how can the things that we discussed in analysis can be done actually. The output of the design stage is actually an implementation specification by using a programming language of your choice. Now you're ready. You did the analysis, you've done the design. Now it's your turn to pick up any programming language that support object-oriented perspective and go on. So once you are ready of your analysis and design, it's the process now to convert that into a final product. You have a few options of sample programming languages that support the framework or architecture of object-oriented. For example, you got Python, C++, Java, C#, Swift, you got Ruby, and so many other languages actually recently new. They support the framework of object-oriented. In this training, we are going to pick Python as one of the popular languages, but it doesn't restrict you of applying the same concept in any other of these languages of your choice, as long as the object-oriented architecture is in there. Now let's put everything together what we have been talking about. Object-oriented, it's very clear how these 2 terms formed this architecture, and then we brought the analysis feature to it to speak what need to be done in this stage, in the design, how to be done, and finally, of course, is to implement this using any of the available programming language. I hope now the term of object-oriented and its relation to analysis, design, and programming, and how each one of these steps are completely relevant is very clear. Now it's the time to move to the next outline, and that is to discuss procedural paradigm versus object-oriented paradigm. I'll see you then.